All right, welcome to our next video in our series on programming in Java. Our objective today is we're going to write a program called MirrorPrinter, whose job it is to print out the image of a mirror using keyboard art or ASCII art. What we're looking for is something that looks like this. If we have a shape loosely resembles a mirror, we say it's size 10, I want it to look like this. If it's size 8, I want it to look like that. We can see the evidence of those numbers in that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows in the size 10, and there are 8 rows in the size 8. So how do we do this? How do we break this down? Well, a big theme of this video is going to be pseudocode and planning ahead. So pseudocode and planning ahead. What does that mean? Well, it means if I am going to look at this shape, I should recognize what are the patterns, what are the components of the mirror. And the first thing I'm going to observe is that the very top and the very bottom are identical. So rather than make two print statements whose job it is to manage the top and the bottom, I'll make one method. And I will just call that method wherever I need it. The other thing I'm noticing is the top and the bottom are different widths depending on what the size is. So I'm going to make a note to myself that this method who prints out the bar should change how wide the bar is depending on what the size is. So I'm going to head over to my code, and I'm going to map something out in what's called pseudocode. So pseudocode is a kind of planning that a programmer does before they start a project. It's where you can think out your ideas and say, what is it I'm trying to do? And what methods should I use? Will I need loops? Will I need variables? What are all the different parts of my project? How do I see them connecting together? And a good practice that I highly recommend people get into is you can just kind of plan out what your code needs. Some people will say, well, it looks like we're going to need to print the bar, and then we're going to need to print the upper half of the mirror, and then we're going to print the lower half of the mirror, and then we're going to print that bar again. So I see I'm going to do print bar twice. I only need the one method. So I'm going to go ahead and describe what my methods are up here. I'm going to do print bar, print upper half, print lower half, and print bar again. Okay. And we're going to define down here what those things do. So I'm going to need these are all methods that I'm calling, but they don't exist yet. So I'm going to comment them out. And what makes this a cool strategy is, as I build each of the components, I can uncomment that component, compile it and test it, and see if it works. So let's go ahead and define that first method first. So public static void print bar. And we recall, I've got a little text file here. You can make a README reference for your project too. If you just click on this little piece of paper right here, it will create a text file, or it'll give you access to the README text file. You can put whatever you need to in there. So the default for size 10 looks like this. So I'm going to just make myself a note. So this is the size 10 looks like this. And I'm thinking to myself, all right, well, every one of these starts with a pound sign, the hashtag, and it ends with the hashtag. So let's make sure we get those two things in there. System.print, we're going to do the hashtag. Okay. And then it's going to end with the hash. Okay. But somewhere in the middle, I need to print out a bunch of these equal symbols. And what I'm observing is, I think if I've done my counting right, let's double check the counting. Between the two hashtags, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 16 of these equal symbols when the size is 10. There are 12 when the size is 8. So every time the size goes up by 1, I seem to get 2 more of these symbols out. So every time size goes up by 1, I get 2 more symbols out. But I don't have 20 of these, so it's not going to be just size times 2. Kind of feels like it might be size times 2 minus 4, something like that. Let's test that theory out. So if size 10 gives me 16 equals symbols, if I double this, I get 20, and I subtract 4, I get 16. That gives me the right symbol. For size 8, it's 12. So let's see if our formula works again. We need 12 equals. If I double it, I get 16, and then I subtract 4, and I get 12. So we have figured out what the relationship is between size and the number of symbols we want put out. And if that felt like a complex done quickly, the answer is this is why your pre-algebra and algebra teachers had you relate two values to each other. What's the input? What's the output? X is my input, size was my input, and then the number of equal signs was my output. So you could create a y equals equation out of this. It would probably look something like, oh, is this the end of my document? Oh, there it goes. Okay, I was about to say. Y equals 2x minus 4, where y is the number of equals and x is size. So we use size as input, and we double size and we subtract 4, and that gives us the number of equal signs. So why do we use this skill? Well, we're going to need it because we got to figure out the relationship between size and the number of spaces, size and the number of dots, size and the number of rows. There's going to be a lot of times we got to figure out, all right, when size is this, how much of that output do I get out there? So I know that my formula is going to be number of equals is 2 times size minus 4. So I'm going to head over here and we're going to say 4 into I equals 0. I less than, and here's where we can use our formula. We're going to say size times 2 minus 4. Look how I leave nice spaces between all of my operators. I find that if we take code and we smush it together like this, doesn't that just look less readable? See, I don't think that looks as nice. Put a little space around your operators. I think you'll thank yourself later. But what have I forgot to do here? Well, I'm referring to a class constant I want to use in my program, and oops, I haven't even programmed that in yet. So let's get that in here. Global variable, class constant, public, static, final, int, all caps, size, as to emphasize that it is constant. Once I've assigned it the value 10, it cannot change again. All right, so every time this loop runs, system.out.print, we want one equal sign, and I want to make sure after the last hashtag is printed that we go down to the next row. So I think there's a chance this print bar method is done, but it's hard to say. And remember, before you try and just lay out 100 lines of code and hope that it works, it's good to test each component, each piece of your code at a time, and see if we like the way it looks. So I'm going to run over to my file selector, run that main method, and look at that. I think I get 1, 2, 3, 4, 5, 6, 7, 8, 15, 16. We got what we wanted. We could change that size to 8 and see if it looks like it lost 4 symbols, which is what we're shooting for. Boom, nailed it. All right, so we've got the print bar. Now it's time to do the trickier part of this project, the upper half of the mirror and the lower half of the mirror. So I'm going to do some planning first. I don't want to just plunk code on the screen. I want to say, all right, when I do the upper half and when I do the lower half, what do I see? And the best thing to do is go ahead and just highlight one of the rows that you're working on and identify all of the components of that row going from left to right. I notice that I start with one of these vertical lines in programming that's called a pipe. So I start with a pipe. Then I get some quantity of spaces. Then I get less than, greater than. When you put these together, it's called the diamond operator. So we've got pipe, spaces, diamond operator, dots, diamond operator, spaces, pipe. Each one of these things needs to be represented in my code. So let me go back to the mirror, to the code itself, and let's get this upper half part done. Public static void print upper half. And let's just identify the pieces. Let's pseudocode this out, right? So it's a pipe, spaces, and by the way, the amount of spaces was decreasing as I went down. Spaces, diamond operator, dots. This was increasing. If we go look back at the pattern, we get another diamond operator, and we get spaces, still decreasing, and then we get that vertical pipe again. So I've gone ahead, I haven't written any code, I haven't tried to make anything work yet, and already I'm laying out the structure for what it is this method needs to accomplish. So let's go ahead and build those parts in. The things that I know only need to happen once, like the pipe and the diamond operator, I can just write that code in right away. So we'll say, I'm going to go ahead and replace this line. If this were a more descriptive comment, I would want to keep it for reference to see what my initial design was, but it's just something that's going to get replaced with an individual print statement. So I'm okay replacing it. System.print, and we want a pipe, and it looks like that. And not only do I need that line here, but I need that line here. And except at the very end, we're going to make that a print line, because when I get to the end of the row, after this last pipe, we want to go down to a new row. All right, so now let's get the next easiest thing out of the way. We need the diamond operator printed. I'll just paste in my old print statement line, but I'm going to go ahead and replace the pipe with the diamond operator. And I'll do it right there. Now, I've gotten a good bit of this accomplished already, and if I wanted to, I could go test that code, make sure it's working the way I want it to. Oops. It's not going to work if you don't uncomment it, though. Yeah. Run it. We can see the components are in there for each line. But what I haven't accomplished yet is we got to realize that these patterns of pipe, spaces, diamond, blah, 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 it isn't happening just on one row. It's happening on many rows. And so let's go check out the relationship between the number of rows and what size is. So just looking at the upper half, and I'm gonna take out all of my old algebra, and let's see if we can figure out the question we're asking ourselves is how does size affect number of rows? Should that be an effect? I thought it was affect. I think it's affect. Well, I notice when size is 10, so we'll just map this out right here. When size is 10, the upper half of the mirror gets 4 rows. When size is 3, when size is 8, we're gonna get 3 rows. So what do I assume the relationship is? Well, it seems like rows equals size divided by 2 minus 1. That seems to be the relationship. You cut it in half, and that gets you close. If I cut 10 in half, I get 5. If I cut 8 in half, I get 4. But it's still 1 too many, so we'll cut it in half and subtract 1. So let's see if we can get at least the correct number of rows out of this. So everything that I'm printing, all of these symbols need to appear on one line. So it's 4 int I equals 0. I less than size. I plus plus. And then we're going to close it right here. That should work. Oh, is it mad because it wants all these things moved over? Okay. So now you've got, hopefully, the correct number of items. Oh, geez, but I didn't even use my formula. It's not size. It's size divided by 2 minus 1. Let's see if that does what we want it to do. So when size is 8, did we get 3 rows for the upper mirror? When size was 8, did we get 3 rows? Boom. Look at that, we did. Let's test it again. Rigorous testing yields to good products, ergo a good grade. When we said 10, it gives us 4 rows. Oh, something I should mention is we are going to disregard odd sizes. And the reason for that is, if I look at my shape, it's easy to do 10 rows. But if I'm going to do 9 rows, I only have to cut 1. Which is the row that's going to get cut? Is it the part of the upper half? Is it part of the lower half? There's no way to do this symmetrically so that the top half of the mirror looks like the bottom half. I mean, I guess you could. You could make it look like this. But that is a significantly more challenging problem, so we're just going to disregard odd sizes for now. All right, so we're heading back over to MirrorPrinter, and we see, okay, we've got the correct number of rows, we've got the right spaces in each row, or we've got the right symbols in each row. Now I need to start printing out a quantity of spaces and dots and spaces. And I'm going to remember that if I want there to be more spaces at first, and then fewer, and then fewer, and then eventually none, then I need to have one of those shrinking or reducing outputs, which means I need a for loop in here. And let's give it some space so we can see it work. For int, remember I can't use I is still in scope here. I is the index reserved, is the identifier reserved for the index of the outer loop, so I can't use that. So I'm going to say int I equals, and then I'm going to pause, and I'm going to remember, if I'm going to do some of these reducing or growing outputs, then I need to care about the index of the outer loop. So, sorry, that should be j equals. So am I going to put I here, or am I going to put I in the test? Well, remember, to be reducing, we should give ourselves a lot of space to work with it first, and then we should shrink down and shrink down and shrink down. So what I'm going to do is I'm going to say, all right, start j at I, and I'm going to say j less than, and I'm going to give it the same target from up above. I'm going to say size divided by 2 minus 1, j plus plus. Okay, so now let's go ahead and print out a number of spaces. All right, so let's see what that does. We're going to print out a number of spaces equal to size divided by 2 minus 1, starting j at I, but every time this runs, I will have gotten bigger and bigger, and that's going to give j a smaller and smaller target to hit. So let's just pause right here and see what that does. Now check that out. That's pretty good. We got a reducing number of spaces, but it's clear to me that I'm not getting quite enough spaces. It seems like what I need is not to print out one space at a time, but to print out 2 spaces at a time. So we're going to do this. And now we can see that they line up a little better, but the loop is running one time too many. And so we need to make sure the loop runs one less time. So to do that, I'm going to reduce the distance from the initialization to the test. So I'm going to decrease from the start to the stop. Now I'd already shrunk the stop by 1 by using this minus 1. I'm going to change that on up to minus 2 and see if that gives me what I want. And just like that, we get a reducing number of spaces. We realized that we needed more space for each line. So the way to accomplish that is I added an extra space right here. We needed the number of spaces on each line to decrease by 1. So I moved the stop in by 1. Okay. So now what we're going to do is we're going to try and figure out the dots. And actually, I'm going to tell you right now, we got to print out spaces that are decreasing later on in the print upper half. So let's go ahead and just copy this code right here and attach this. Down there. All right, so we see again a decreasing number of spaces. And it looks like that's going to give us what we want, but now we got to figure out the dots. So let's go figure out the dots. So this is going to do something a little bit different. We know that the dots is going to be increasing, so we got to get this to go the opposite direction. For int j equals, and then we pause here. All right, so we need one of those increasing outputs. Seems like I should be able to say, all right, when j is 0, j less than I, let's just start with this and see what that does for us. J plus plus, and stop it right there. And when we print out, I don't know, maybe we'll start by printing out a couple of dots, see what that does. So Okay. So we're trying to print out a couple of dots, and we know this is increasing because we've started j at 0, and we've asked j to chase I. So when I also starts at 0, there's no distance, it won't run. But as I gets bigger and bigger, j will have to go from 0 to 0, which is nothing, then 0 to 1, then 0 to 2, then 0 to 3. So we're going to compile this, we're going to run this. And if you look, we actually get pretty close to the right output. You know, what I didn't do is I didn't try to get a formula based on the pattern. So let's see if we can go back to our pattern and have a look. When the size is 10, it looks like I need 4, and then I need 8, and then I need 12. So it does increase by 4 dots every time. So that's a good hint. If I go back to the code and I ask for 4 dots, oops, 4 dots, does that give me, oh geez, does that give me what I'm looking for? And sure enough, it does. Now, it can be easy to try and celebrate too early and say like, oh, I'm done. But until you've really tested it, you don't know if it's doing what it's supposed to. Let's try it on size 12 and see if that scales. Boom. Let's try it on size, I don't know, 4. Let's see what a little baby mirror looks like. Ah, is that even right? Shouldn't there be? Oh yeah, because that's just the top half. That's what the size 4 would look like. When we get the bottom half of the mirror in there, it's going to do the right thing. All right, so we've done it. We've built the upper half. All we had to do to start was say, look, let's build a for loop that has an increasing output, and then we can modify the components of this for loop as we needed. And it turns out the only thing I needed to change was the number of symbols printed. I could have ended up needing to make a formula as a part of the test. I could have modified where I started to change the number of times the loop ran, but we were able to strike on this one pretty quickly. So once we've gotten the top of the mirror, what's cool is the bottom of the mirror is really all the same concept, just go in the opposite direction. So what I'm going to do is I'm actually just going to copy my print upper half method, and I'm going to make the changes I need for the lower half. So let's go in and change print lower half. So let's change the number of rows we need is the same, right? If there are 4 rows in the upper half, there will be 4 rows in the lower half. If there's 3 in the upper, then there's 3 in the lower. So we can use the same outer loop logic, which is size divided by 2 minus 1. The other cool thing is all the symbols still appear in the same order. It still goes pipe, spaces, diamond, dots, diamond, spaces, pipe. But what's different now is we got to change the spaces are going to be increasing. The dots are going to be decreasing. And these spaces are going to be increasing. And I think it's fair to say that we're going to need the same spaces increasing loop with a for loop that we will above. So if we can get this for loop correct to project the number of spaces that begins each row in the lower half of the mirror, then we'll have the same for loop on the other side as well. So I look out, I'm going to go ahead and just ditch all of this logic. Let's just start fresh. Int j equals, and I pause, and I think to myself, all right, are we increasing, or are we decreasing? All right, we're increasing. The tool for increasing was start at 0 and say j less than I. Now, I don't even know if that's correct. We're just going to start with that, and we're going to see what that does. So we've changed to a size value that makes sense. Compile. Oh, let's go ahead and uncomment to see if that works. And we're not going to expect the dots or the spaces on the right-hand side. We're just looking for the spaces on the left to see how that does. And check that out. That actually looks pretty good, right? We got all of the left diamond operators are lined up where they're supposed to be. Oh, and that's funny. I forgot to remove the dots. The dots are still increasing down here where they're supposed to be. They're still increasing where they're supposed to be decreasing. Okay. So then let's go ahead and just copy that spaces loop over here because we need the exact same kind of spaces on the way down, right? A little bit and then more and then more. The decreasing means we got to do the trick where we start at I, whatever the index is of the outer loop, and then we're going to have to stop j less than. This is usually going to be the subject of some kind of a formula. I'm going to say size divided by 2 minus 1 just to start us, and let's see what that does for us. So I'm going to run that. All right, so I'm looking, and it looks like we got the loop to run one too many times. It needs to run one fewer time. So I'm going to change this to a -2, recompile that, and see what that does. Boom, and we got it to work. Why does size divided by 2 minus 2 work? Because the number of times that I need 4 dots has a relationship with size. If you chop size in half and take a couple away, that's the number of groups. So when size is 10, I needed 3 groupings of 4 in this first row. Then when size is, if size is 8, then I'm only going to need 2 of those groupings in the first row, which I can show you. So I've got 1, 2, 3, 4, 1, 2, 3, 4. Just gave me 2 groupings. And then, so size divided by 2 means you cut 10 into 5, and then you subtract 2 because you just need that many groups. All right, so we want to make sure that we test it. We want to make sure that we comment it. Let's do size 20, just so we can look at something kind of extreme. And look at that. There it is. It scales. So in summary, these problems are challenging, and this should be setting us up for a problem we're going to do called book printer. But the idea is you want to design out what your pattern is going to be, build those methods one piece at a time, and when you're dealing with the complex parts that are going to require an inner and outer loop, break that down into components. What are the symbols you need one of? What are the symbols that you're going to need a varying quantity of, whether that's spaces or dots? And then don't worry about hitting it exactly correct the first time you print it out. Just make something, if you know you need decreasing, make a decreasing loop, and then begin to modify based on the needs of your output. If you need increasing, make an increasing loop and begin to modify. You can also totally try to do the algebra to figure out what it is that you need, but whichever one works best for you is totally fine. All right, thanks for watching.